Today we are going to discuss about the first practical of electrical drives and circuit. The practical name is three-phase speed control of three-phase induction. Following apparatus should be useful. Maybe three-phase induction machine, DSO, that means digital storage oscilloscope, drive controller, as well as some other equipment. You can see here there is one induction motor which is loaded by externally. You can adjust the load by setting this. You can increase the load, you can decrease the load. Then three-phase is connected with our controller where you can first of all see there is the input switch which indicates the availability of supply. This one is one of the MCB useful to working as a one of the switch as well as the overcurrent applications. Then there are two additional inputs where the supply has to be connected. Then you can see there is one rectifier, single phase full wave rectifier. The function of single phase full wave rectifier that you might be knowing in the lectures. In short, it will convert AC into the DC. Every time we are using this DC in whole day-to-day life. Right now the available DC needs to be connected properly with the three-phase bridge circuit. Basically this is our heart of the circuit. The three-phase IGBTs are used, six IGBTs are used, and 6 gates G1, G2 to G6, they are connected externally by means of G1, G2, G3, G4 and G5 as well as G6. The complete control circuit diagram is inbuilt with the circuit. So if you want to see it, we can open this. And right now we assume that there are 6 gate pulses available at our circuit. You can also see another side, see there are 3 outputs. Number 1, you can see U, V and W. These 3 are the feedback sensors. You can take the feedback of induction machine in terms of the speed, in terms of the frequency, as well as the load, output voltage. These 3 parameters can be given for the feedback of the controller. The controller will monitor the output, monitor the speed, and as per that actual speed, actual voltage, it will try to rectify the position of firing angle and provide proper firing signal to our power circuit. On the left hand side you can see there is a microcontroller, one of the display, then some of the settings has been given. You can adjust, you can see this up frequency, start or stop button, enter, mode and down frequency. Basically only 3 functions are there. One is to increase the frequency, to decrease the frequency, as well as start or stop frequencies. So this is very simple circuit to understand properly. In short, basically it converts supply, then power circuit, control circuit, then there is a display as well as additional circuit is the machines. All of these load. Now we are going to perform this practical. We are trying to see only the performance of this induction machine based on the frequencies. We are studying every day that what happened inside the machine, inside the induction motor when there is a change in the frequency. There are basic equations we already studied about the frequency, above base frequency, below base frequency. There is a problem of saturation, core saturation, many others. But we are not going in detail of this all frequency control. Let's see what's happened when the frequency is going to be changed. So first of all, we need to supply this. We already connected this. Additional is digital storage oscilloscope. That is, we already connected for the measurement of the gate pulses as well as all other parameters. Initially, this all 3 should be on. This is on. Then after what we will do, we will make the circuit on. This switch indicates that the circuit is running. Yet we have not connected with the main supply. Before connecting to the main supply, let's see some of the output voltages as a gate pulse. See, there are 1, 2, 3, 4, 5, 6 switches are there. As per the timings, we have to provide the gate pulse. And we all know that about the gate circuits and many things in previous semesters. So in short, whenever there is a presence of the gate pulse, that switch is going to be closed. For example, if gate pulse G1 is present, G6 is present, that means G1 and G6 both are connecting. As a result, what would happen? The supply is connected with, the positive supply is connected with the G1, which is connected with the G4 and then back to the neutral. In this way, the supply is connected with the positive terminal, G1 terminal as well as G6 terminal, and then back to the neutral. In this way, the circuit is going to be complete. So let's see what is the gate pulse. You can see the G1 gate pulse over here. In short, we need to start this. If we start this, you will see gate pulses are there. See, the gate pulses are present. You can change this duration by changing the up frequency or the down frequency. Similarly, if you want to see the another pulse, the pulse of the another switch, for example G3, or you can say G2, G1 or G2. You can see both pulses are present. The important point I want to mention over here is whenever the pulse 1 is present, at that time the pulse 2 should be 0. That means both pulses should be opposite to each other. That means if G1 switch is on, at the same time G2 should not be on, it should be on. So this is very basic simple idea. In this way we are going to provide a proper firing pulse to the all switches. Now let us make this circuit on. By doing this, you can see the speed of the machine. We can also measure it by tacho generator. Otherwise, you can see it from here. The speed of the machine is this. The actual frequency is this, and all this you can see it. Now you can adjust this frequency. You can toggle this switch. This is one. This one is for the external sources. This is for the internal sources. You can change the frequency. Okay. You can start our machine by pressing this switch. You can also adjust the frequency. You can see 25.2. You can also increase 25.3. Similarly, you can go up, you can go down, you can change the speed. You can see the difference in the speed of the machine. See, there is a small variation in the frequency in terms of the points. As a result, you will not get maximum changes in the speed. But if you go up to the 50 or 60 somewhere, you will change the maximum speed. You can see the maximum speed. So in this way, you can do many things with this practical kit. You can also, right now it is working with the fixed load. It can be increased further automatically. There is a load on the machine. You can measure the current as well as you can see the speed is going down. It is 724. If we increase the load, the speed is going further decrease. You can release the load and the speed might be increased. So here, now I leave it to you. You can perform this practical. You can see various parameters, changes in the parameters, and if there is any doubts, you may make it up.